follow up the product rule with the quotient rule. Quotient rule, of course, is used when you have a quotient of two functions. For example, let's say our function is sine of x over cosine of x, right? Which, hey, that looks familiar. Isn't that tangent? Yes, it is. So let's say we want to take the derivative of f of x divided by g of x. And as normal, we're going to go to our trusty limit definition to derive this. So the limit as h approaches 0 of f of x plus h over g of x plus h minus our original function f of x over g of x, all divided by h. So first thing we're going to do is get our denominators taken care of here. So my common denominator between all three of these will, excuse the bell, we'll have another one coming up in 5 minutes here. The common denominator of all three of these will be the product of these three. So what we need to do here is let's give ourselves a nice little denominator. So in the numerator, we have f of x plus h times g of x minus f of x times g of x plus h. So I've combined my numerator of my numerators with g of x plus h and g of x being the denominator. And of course we recall that our denominator h will then jump up with these guys to form that. We'll put this guy in parentheses so we can distinguish between them. Much like with the product rule, we're going to have to do a fancy form of 0, although this form is not nearly as fancy as with the product rule. So in the middle here, we are simply going to throw in an f of x and a g of x. F of x times g of x plus f of x times g of x. And as you can hopefully see, that is nothing more than a fancy form of 0 that we mixed in there. So as we finish writing this out, we got that big, long, drawn-out denominator, h times g of x plus h times g of x. And at this point, we're going to start separating it up to give it some more flair, some more flavor, and a little more meaning to what we are attempting to do here. So the first thing I can do is I can take a g of x out of right here. If I pull that g of x out, I'm left with f of x plus h minus f of x. And I think you can already see where I'm going with this. Over here we can pull the f of x out. F of x, and I pull out, I get g of x minus g of x plus h. And that one might concern you a little bit, but let's keep going with it and see what we get. So limit as h approaches 0. I'm going to start rewriting a little bit now. G of x and f of x plus h minus f of x all over my denominator, which is that combination here. We're just going to do h for now, though. Now up here, notice these guys are in reverse order. I want this guy first and that guy second. I want this guy negative and this guy positive. So I'm going to actually factor out a negative and change this to minus f of x. And now my g of x plus h is my leader. He's positive. My g of x is negative. He's following there. I'm going to put my h there, and I'm going to kind of unsimplify the denominator. I put my g of x plus h and my g of x down here. Now, I know you all think I'm incredibly clever because I thought of that, but I really didn't. I just recall it. So what we have here, we nicely have our limit definition for the derivative of f, our limit definition for the derivative of g. And down here, remember, we're taking the limit of this whole big fraction. The limit as h approaches 0 of g of x is g of x. The limit as h approaches 0 of this is f prime of x, minus the limit as h approaches 0 of f of x is just f of x. This limit up here is g prime of x. And this is all divided by, look at what we get here. H is going to 0, so we have g of x times g of x, which is nothing more than g of x squared. So in short, the derivative of f over g is g f prime minus f g prime all over g squared. And let's look at our example we had earlier, which was the derivative of sine over cosine, or tangent, right? So you might not think that the derivative of tangent is a quotient rule problem, but in fact, tangent is the ratio of two functions, sine and cosine. So in order to find the derivative of tangent, without just looking it up, because that's just boring, we would actually go and take the derivative using our new quotient rule. So let's scroll up a little bit here so we can see the quotient rule. So it says to take the g function. Well, g is my lower function, so I'm going to take cosine. And now the derivative of my upper function, the derivative of sine, is cosine, minus my top function times the derivative of my bottom function. The derivative of cosine is negative sine. And that is all over my denominator squared. So a little bit of algebra here. We get cosine squared plus sine squared. That appears familiar to me. Let's see, I remember from my math analysis in trig class last year that cosine squared plus sine squared is a Pythagorean identity. That's equal to 1. 1 over cosine squared is the same as secant squared of x, and there is the derivative of the tangent.